Hey gang, so I actually haven't worked these yet, so I'll just work them through. So that means I'm going to be putting everything into my calculator on this because I don't have an answer key for this. Okay, so the molar mass of gold is 1.97 times 10 squared gold per mole. How many moles are in this much of the gold? No, a mole is just a fixed amount of a substance. So if the molar mass of gold is 197 and 10 grams, and there, how many moles are there in this? So couldn't I just take 583 times 10 to the 5th and divide it and see how many 1.97s times 10 squared, how many I get? So alpha y equals, and I'm going to do 5.83 times 10 to the 5th power, and on the bottom I'm going to do 1.97 times 10 the second. Okay, so here's what I got. I got 2959.390. I'm just going to stop right there. Actually, I'm going to go ahead and put all of it there. There it is. Now, I want to put that, though, in scientific notation. So I'm going to look at my first 3 sig figs. The 9 is going to change that 5 to a 6. So I'm going to do 2.96 times 10 to what power? So I need to move this over. So it's going to go over 1, 2, 3. It's going to go right there. So I moved it over 3. There we go. All right. The next one. If this times this equals this, find the value of K. Okay. So I'm going to have to think about this a second. I think I want to pull this apart and say, because this is just multiplying, right? Can I say 9 times 8 and 10 to the 6th times 10 to the K equals, and then I'm just going to break this apart to 7.2 times 10 to the 15. Okay, 9 times 8 is 72. So let's do this. Let's take, which way do I want to go? I want to get rid of this right here, I think. So I'm going to do 7.2 divided by 72. So I end up with 10 to the 6th times 10 to the K equals 0.1 times 10 to the 15th. Okay, I need to get rid of okay, so if I wanted to change this to like, well, let me just leave it here for now. I'm going to divide both sides by 10 to the 6th. There might be a shorter way to get there. I'm kind of thinking out loud as I do this, kind of going, why did I not make a answer key for this? Okay, so those would cancel, and I would get 10 to the K equals 0.1 times 10. I'm going to, if you remember your laws of exponent, we're going to subtract there, and that'll be to the 9th. So for ease to help you understand this, I'm going to do 0.1 times 10 to the 9th power. Let's see what that comes out to be. So that gives me 10 to the K, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Could I say 10 to the K equals 1 times 10 to what power? 1, 2, 3, 4, 5, 6, 7, 8. What does that tell you about K? K equals 8. Is there other ways to get there? Absolutely. I was trying to take the simplest one that's the least confusing. I feel like that worked. Okay, so the radius of a circle is measured by 3 centimeters to the nearest ½ centimeter. Calculate the maximum percentage error in the area of the circle using measured values. Okay, so area equals pi r squared. The radius of a circle is measured to be 3 centimeters to the nearest half centimeter. Okay. That means that we're going to have a range here. So we're going to have to say that it's pi r squared. If we go to a half centimeter, so that means it could be 2.7, is that right? Let's do 3 minus 0.5. So it'll be 2. Did I do that right? My notes, my answer key on this one did have something different. If it's to the half, so that means it could be 2.50 less than or equal to the radius. The radius of the circle is measured to be 3. Or it could go the other direction and be, oh no, that's right. It would, okay, sorry, I'm thinking out loud. If the radius, okay, how to explain this so that I don't lose you on this. The radius is 3 centimeters. Okay, it can only be a half centimeter off, which means it could be from 2.75 all the way to 3.25. The reason why is this distance here is 0.5. Okay, which means I'm not going to be a whole half centimeter this way, because if I was, I'd be too far. I couldn't go that far. So it would be 2.75 this way and 3.25, because that distance adds up to 0.5. Okay, if I lost you on that, come see me, and we're probably going to do this one in class anyway, so it won't matter. All right, so let's find the area if we have a 2.75. So let's do pi times 2.75 squared. Let's find that area. I did not leave y'all enough room to work this one. 2.75 squared times, and I'm going to do second pi over here. So that's going to be, I'm going to put as many of them as I can. 23. This is the exact, right? And I might even want to use that as my exact. So 23.75829, and then a bunch of 4s. 4, 4, 4. That's the exact. Oh my goodness, that's going to be a mess. Okay, so now let's do the other one. Area equals pi r squared. Let's do the, think of this as like the lower boundary. This would be the lower area. Now let's do the upper area. Area would be pi times 3.25 squared. So this area would be 3.25 squared times pi. So this one's going to be 33.183,183,0724. All right, and so there's our upper. So now what we want to do, what did this problem ask us to even do? Calculate the maximum percentage error. So I've got those. So now I need to calculate the exact. So this is approximate at 2.75. This is approximate at 3.25. I know that the radius is actually 3, right? So let's go here and let's calculate pi r squared again. But this time let's do with the exact value, which we already know was 9. So the area equals, and I'm going to do 3 times 3 is 9. So 9 times pi exactly is 28.2743338. Would it be easier to probably leave pi in your answer? Yeah, it'd probably be a whole lot easier if we did that. Okay, so the largest percentage error for this estimate of the area of the circle, it's gonna occur at one of those boundaries. I don't know if the bigger percent error is going to be here or here. The lower bound had 23 and the actual was 28. The upper bound had 33 and it could go either way. So let's do this. I'm going to change colors and I'm going to say the lower percent error. Okay, so for the lower percent error, I'm going to call this, are y'all okay if I put like this? If I put this A1, A2, and A3. Maybe we, you know what, instead of 3, I should have put an E. Let's put E on that for exact. Just because I don't want to have to rewrite all that, I'm going to use these numbers down here. Okay, so for this one, we're going to say we're going to take A1 and subtract it from A exact and divide by A exact, right? Times 100. Let's get that percent error. Okay, so here we go. We're going to do the lower boundary. 23.7582944 minus this one right here, 28.2743388, and we're going to divide that by this again, 28.2743388. Now remember, we're not going to worry about the negative because we're going to be taking the absolute value of it, but we are going to say times 100. Okay, so this gave us 15.972%. Okay, now let's do the upper. The upper percent is going to be A2 minus A exact divided by A exact times 100%. If it's bigger than 15, then we would know that would be our bigger error. So, come over here. I'm going to do alpha y equals on this one. I'm going to do 33.1830724 minus 28.2743388. On the bottom, 28.2743388. Times 100. Okay, so this was 17.3611. Okay, my notes I got a little bit different, but I got that the lower boundary was a little bit different. Let me make sure my numbers. 28.2743 divided by, I got those mixed up. They're saying that, I was looking on my answer key, that this one goes on bottom. This is, okay, a radius of a circle is measured to be this. Wouldn't that mean that my exact was using the measured value to calculate the estimate? Okay, well, I'm going to do this again in class, and so we'll see what happens. What it's saying on here, what we did if we'd done it right, we would say that this one has the greater percent error, so we would say the upper boundary has the larger percent error. They're saying it's the lower one because this number down here, I thought that the 3 was the exact, but since you could have you can go error either way, they're saying this is the exact because this is how much you can deviate either side. 3 is kind of like the average, and so this should be what you're subtracting from. This number should be on the bottom. So if I were to rewrite that, instead of dividing by the E, this would be divided by A1, and this one would be divided by A2. When you do that, you end up getting on the lower bound 19, and on the upper bound 15, 14.7, which is 15. So anyway, if you want to rework that, I will rework it in class. I'm going to put a mark right here, and I'm going to say this comes out to be 14.79. This one comes out to be 19.008. I will have, hopefully if you were in class, you got a better explanation on that one. So anyway, when I explain it in class, I'll have all the kinks worked out. All right, and the last one. Okay, these should be pretty straightforward. Round this to 3 sig figs. So remember, we're going to look at the first whole numbers, excluding 0. So this is 1, 2, 3. We're only looking at the 1, 0, 3. The 8 is going to round the 3 up, so this would be 104. Then I'm going to look at those first 3 digits, 1, 2, 3. The 2 will not change the 8 any. Oh, sorry, this says round to the nearest hundredth. Well, that's where I'm at. So 4.9 is the tens, 8's in the hundreds, and the 2 does not change the 8. All right, is that the last check for understanding stuff, or do we have a little bit more? Nope, that was it. All right, thanks for watching. Sorry for the confusion.